Hello, everyone. Thanks for joining us. My name is Tom Suter. I'm the founder of the Advanced Technology Academic Research Center, and we're here for a panel on artificial intelligence in your agency to ensure mission success. And today we have with us Nick Saki, who's the Principal Systems Engineer at Pure Storage with us today. How are we doing today, Nick?
Doing great. Thanks for having me today, Tom.
Yep, looking forward to your talk. Thank you.
Thanks. Well, very excited to have the opportunity to talk today about using artificial intelligence in federal government agencies to improve agency support, constituent services, and mission operations. We've seen a tremendous uptake in adoption of artificial intelligence technologies, and certainly a tremendous interest across the federal government as a whole. In the Department of Defense in particular, we've seen the establishment of commands of agencies specifically focused on developing and deploying artificial intelligence. We've seen it implemented across the entire spectrum of the federal government, and broadly also across a lot of the state and local governments as well. But we've gotten past a lot of the initial level setting questions around, an AI strategy and a data strategy, and all of these things are really fundamental to enabling the implementation and the effective implementation of artificial intelligence in government organizations, just truly like the adoption of any advanced technology. We've also seen that it is no longer theoretical, that it's actually a practical and real capability that agencies can leverage in order to support their efforts, whether it's, obviously, taxpayers and revenue, or Department of Defense operations, intelligence community, et cetera. But there are still a lot of significant challenges ahead of a lot of agencies as these efforts come out of the laboratory or out of the pilot and proof of concept stage and into a production or deployment type of environment. So what we see is there's a lot of questions or challenges around what type of technology to implement, how you implement it at scale, what types of applications are suitable for implementing an artificial intelligence or implementing artificial intelligence and machine learning at scale. People, the availability of people, where do you get the expertise? What skill sets need to be developed in the workforce or brought into the workforce and are able to get the most out of an agency's artificial intelligence efforts? And I think I really want to sort of take these things in that kind of a track. First and foremost, you've got to identify what it is you want to do or what you hope to accomplish with an AI strategy. And at the outset, a lot of this has been tackling repetitive, large-scale data operations, if you will. So the federal government generates data in quantities, volume, variety, and velocity that many people don't really fully appreciate. But a lot of this data, for example, camera imagery is agonizing. It takes a tremendous amount of time for an individual to look through streams and streams and streams of video, but it is actually a task that, as an example, computers are really good at. So just doing machine learning, or computer vision, I should say, in machine learning, to start identifying relevant contextual information in video streams or massive collections of still frame imagery has become a very popular use case. And we've been pretty successful in helping agencies leverage that for everything from cancer research to intelligence and battlefield surveillance. But getting a sense of what is in the art of the possible is also, I've seen federal agencies do a tremendous job working with industry and academia to tackle these kinds of challenges, because while the specific outcome of a given AI application may be particularly specific to that agency, the computer technology underneath it is actually rather broadly available and broadly utilized. So everything from the algorithms to the actual hardware themselves are often portable. So you can, the government's done a good job of identifying best practices and most successful implementations in companies like Page AI and Facebook and others, and bringing that expertise or those application skill sets in-house to apply to the government's problems. This also sort of at the outset underscored something, that the initial pilot efforts may have been built off of like a single GPU platform or, fairly robust but pre-existing legacy architecture. And that sort of introduced another challenge. The infrastructures of yesterday were really designed to do much more generalized types of computing at a much smaller scale in terms of overall parallelization, the breadth and number of processes that were simultaneously trying to process data was very different in the classic, database and server virtualization type of architecture. But in artificial intelligence, the need for massive parallelization has really driven everybody towards a technology baseline that focuses on distributed and parallelized compute, largely using things like GPUs and tensor processing units and things of that nature, because you have so many different processes working simultaneously, answering segments of the problem in parallel. Well, that poses a tremendous strain on legacy infrastructure. So companies like mine have been not forced, but really moved to develop a technology baseline, a framework that is built for artificial intelligence type applications. And we've seen the popularity of that emerge, particularly as large organization and government AI efforts have started to expand beyond the laboratory or the testing phase and into the real training, development, and production phase. So we're seeing, tremendous increase in the requirements for bandwidth, a huge increase in the amount of compute required, and really you start seeing these large-scale disaggregated architectures where compute, networking, and storage are managed as separate components to facilitate the easy and rapid scaling of the technology infrastructure to support the actual work. And then when we start taking a look at skill sets as well, we've seen the rise of a really different kind of specialist, the data scientist, and the rise in a different kind of infrastructure engineer and administrator. They're two different kinds of things. A data scientist is really figuring out not only how to ask the questions, but what can the data tell them, and then how to get the answers out of these vast data sets. And on the infrastructure side, obviously, when you start talking about managing your on-premises architecture as if it were a large-scale cloud, it's a different way of thinking about the architecture itself. It literally is that as a service type of capability where you've got networking, you've got compute, and you've got data service, and these things get managed but loosely coupled to each other via the applications and application programming interfaces. So it really becomes an almost loose coupling of technology components that get dynamically allocated as the application needs change. And with artificial intelligence, a lot of times that becomes self-servicing. So API-driven automation and API-driven infrastructure become integral to and fundamental to the success of AI platforms, especially as they start to get larger and larger. So, if you think about this in a sort of structural way, the first thing you do is develop an automation strategy. You have your data, you have a data management strategy, and you have a sense of the types of things you want to do with that data. So then you have to develop an automation strategy of processing that data, refining the data, and preparing that data for utilization in the AI framework. And you apply the people to tailoring the data operations and the infrastructure operations to support those outcomes. And eventually you have the core nucleus of technology and people necessary and process necessary to start actually applying the technology against the problem set for the desired mission or agency outcome. So does all that sort of make sense? There's a lot of broad strokes there. The short version is, as well, some of the stuff is new. In truth, it's really a growth in the same types of technical capabilities and capacities that we've evolved over the last 60 years. It's just the scale is now much greater. The velocity of the data is much higher. And we're adapting, as we always do, to making the tools deliver the results that we would like to obtain from them.
That's great, Nick. If I can ask a real quick follow-up question,
Sure.
Where do you see the federal government over the next 1 or 2 buying seasons? Where are we going to see some near-term success?
I think we're going to see a couple of things. We're going to see in-house capability brought on board to start addressing the test and dev, or the pilot and proof of concept phases. And then a continuous iteration and continuous development, or CI/CD, software engineering and AI training mechanism that will very often probably be deployed into a shared infrastructure or a cloud type of environment But I think we'll see the capability development happens in-house, and then the deployment into production will probably happen in large scale, either government owned or contractor owned cloud environments for deployment into the real world. So I think we're going to see a huge increase in cloud spending, particularly around artificial intelligence. And we're going to see a fairly large change in the consumption patterns for on-premises infrastructure as well, and the mandate to ensure that they work together.
Very important. That's all the time we have. Thank you, Nick, Principal Systems Engineer for Pure Storage, Nick Saki. Thank you, Nick, and have a good rest of your day.
Thanks, Tom. You too.